This is a video for MEI Core Pure Mathematics, Calculus 4 Integration Techniques, 4.3 Substituting x equals sine u. Okay, here are some things that you should already know and we have used in some of these videos so far. X equals sine u might be useful in integrating functions involving root 1 minus x squared, because if x equals sine u, then arc sine x, the inverse sine of x, is equal to u. And I also know that the integral of 1 over root 1 minus x squared, so there's that bit, is arc sine x. So it looks like there may be some linkage that will be useful. Remember that arc sine x is the inverse sine of x, and we'll use that throughout these videos, but you may also see it as sine to the minus 1 of x. Okay, let's look at this example. On the bottom here, I've got 1 minus x squared, and I've got a power a half in here, which is going to give me a square root. So I'm going to think about my substitution, let x equals sine u. Differentiating, I get that dx by du is equal to cos u. So when I substitute, I'm going to substitute for dx a cos u du. Plug those in. I'm going to get the integral of 1 over 1 minus sine squared u to the power 3 over 2 times a cos u du. So on the top I'm going to get cos u, and on the bottom 1 minus sine squared is cos squared. This is a square root of that, so I get cos and then cubed. So I'm going to get cos cubed u on the bottom. This ends up as 1 over cos squared u, and of course 1 over cos squared is just sec squared. Okay, so picking up from here then, integral of sec squared is just tan u plus a constant, which I can rewrite as sine u over cos u plus my constant. But I already know from my substitution that sine u is equal to x, and so cos u is equal to the square root of 1 minus x squared. Remember, cos u is root 1 minus sine squared. So I can plug those back in to give me my integral in terms of x plus c. Okay, there it is, tied it up for you. Here's the substitution section. This is the substitution being done and worked through to sec squared u. And then the integral's fairly straightforward. It's the transforming back that gives us a little bit of work to do. Sine u equals x, cos u equals root 1 minus x squared. And so there we have our final result. The original integral is equal to this. And you could check that differentiating this will actually come back to give you the original integral. And remember that to differentiate this, you might write it as x times 1 minus x squared to the minus a half, and then differentiate this as a product maybe to see if you get back to the original integral. Okay, here's a second example. Again, I've got a root 1 minus x squared, so I'm likely to use the substitution x equals sine u, but I've also got limits, and it's important that I transform the limits as well as transforming the variable. So let x equal sine u. dx by du then is cos u, and so again I will be substituting cos u du for my dx. What about the limits? Well, if x equals a half, that tells me that sine u is equal to a half, which means that u is equal to pi by 6. And same story with x equals 0, sine u equals 0, so u in fact equals 0. So I can now do my substitution, transform the limits, substitute 1 minus sine squared u, and then it's times cos u du. 1 minus sine squared is cos squared, square rooted. I'm just going to get a cos from here. I've got another cos here, so this gives me the integral between 0 and pi by 6 of cos squared u du. Okay, let's pick it up from the integral of cos squared then. I can't integrate cos squared directly, so what I'm going to do is I'm going to look at the double angle formula. I know that cos 2u is equal to 2 cos squared u minus 1, and therefore cos squared u is equal to a half of cos 2u plus 1. Plug that in then, 0 to pi by 6 for the integral. The half I can pull outside, and I'm left with cos 2u plus 1 inside. If I integrate cos 2u, I'm going to get a half of sine 2u. Integrate 1, I just get u, and evaluate all of that between 0 and pi by 6. So this is going to give me, plugging the limits in, I'm going to get a half of sine pi by 3. Well, pi by 3 is 60, so that's going to be a half of root 3 over 2 plus pi by 6. And then I'm going to get minus a half of sine 0, which is just 0, and I'm going to get minus u, which is also just 0. So this comes out to be root 3 over 8 plus pi by 12. And again, there's that worked through in its entirety. So here we've got the substitution and the transformation of the limits. Don't forget that. I've done the substitution and used the new limits. And whilst we're there, it's worth noting that you will sometimes see this kind of notation, x equals 0, x equals a half, some kind of integral dx, and then later on you might see an integral with u equals 0 and u equals pi by 6 du with some kind of integral to show that the limits are relevant to the variable that you're using for the integration. And my result is down there at the bottom. Summary then, if we've got a square root of 1 minus x squared, then x equals sine u is a very useful transformation to try. You might not get a simple integral at the end of it. You may need to use another technique after that, and we actually use the double angle formula for one of our examples. And if you've got limits, then they need to be transformed so that you get equivalent values for the new variable. The next video in the sequence is 4.4, substituting x equals tan u.